All right, I'm back. We're on page 315. And what are we going to talk about? We're going to talk about using sign charts to determine where a function is increasing, decreasing. We've been doing this. So if you've been like following the videos, taking the notes, every once in a while, I'll kind of like go off script or go off the note. I don't actually have a script. I'll like deviate from exactly what the notes are asking, and I'll make a sign chart, and we'll talk about increasing, decreasing. So this, if you've been following along, is a pretty straightforward thing. So let's see if we can do it. So we want to state where the given function is increasing, justify your response, confirm your answer on your calculator. Okay, so we're gonna need to find derivatives. So let's do A. Here we go. So f prime is, all right, so 4 times sine is just constant multiple rule. Really, I need to focus on what's the derivative of sine. So the derivative of sine I have memorized is cosine. So this will be 4 cosine. And then the derivative of 2x is 2. And I need to know when that equals 0. Okay, so where does that equal 0? You know what I'm going to end up doing? I'm going to end up graphing this because I think it's easier to do sign charts from a graph of a trig function. But let's like carry this through, right? So I need cosine of x to be -1/2. All right, where does that happen? Unit circle, right? Quadrant 2, quadrant 3. It's going to be at x equals 2 pi over 3, 4 pi over 3. Okay. So I still don't really know what's happening yet, but let's make a sign chart. The way I'm going to make a sign chart here is I'm actually going to graph. Every once in a while, you want to go back and review graphing trig functions. So useful. So let's see. I know I need to go up to 6 and down to -2. -2, 2, 6, right? I'm at 2 and I can go up 4, I can go down 4. It's a positive cosine, so it starts at a maximum here, 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 here. Okay, and then we fill it in. We accidentally tapped the screen there. Oh God. Whatever. All right, so I found the zeros, right? So I know that this is 2 pi over 3, this point right here. And I know that this point right here is 4 pi over 3. Okay, so I'm looking for increasing. So this thing is increasing when f prime is greater than 0. So I know that from 0 to 2 pi over 3, definitely. And then from 4 pi over 3 to 2 pi. So let's write that down. So we'll say f of x is increasing on 0 to 2 pi over 3. So I'm counting 0, I'm not counting 2 pi over 3. It doesn't really matter. I could count both of them. I could count neither of them. Counting 0 because like definitively the derivative is greater than 0 at 0. I'm not counting 2 pi over 3 because I just like don't usually count those. And it doesn't harm you. So that's why I make that choice, but you have to decide what you want to do and then just be consistent so that you don't need to like always have this mental battle every time you face this problem. 4 pi over 3 to 2 pi. And now what is my reason? The sign chart is not enough, right? So I'm going to say because, which I usually abbreviate B/C, which is fine, because f prime greater than 0 on those intervals. Okay, so maybe I should like really highlight. So f prime, this is the graph of f prime. So I was looking for here and here. And then I should label this as f prime of x. Okay, I think that's like a pretty good answer. We're supposed to check this on our calculator. So let's do that. Go over here. Now, how are we going to check it? So we have a couple of options. One, let's add a problem. Let's define the function. So the function is 4 sine of x plus 2x. Okay, I'm going to check the critical points, right? So I want to solve, it's menu 3.1, the derivative. Here we go. The derivative with respect to x of f of x equals 0 for x, but trig functions, super annoying, right? An infinite number of solutions. So I'm going to do such that 0, x, and then 2 pi, and it should like restrict it. Okay, 2 pi over 3, 4 pi over 3, that's good because we got those. Now let's go to a graph, and we can do 2 things. So we should do 2 things. First, let's graph f of x. Let's change the window. so that we can only see 0 to 2 pi. 0 to 2 pi, and then I think I don't see enough, so let's do it again. Menu 4, enter. Let's go, it's like almost never, I think it's actually never negative. Let's go -5 to like 20. All right, that's a pretty good graph. All right, so what can I do? I could find the maximum here. So menu 6, max, click here, click here. Okay, but that's not an exact value, so that's kind of annoying. Let me trace. Menu 5, enter. I'm going to type 2 pi over 3. There, that's the exact maximum. So that's what we found. So function increases until a maximum, decreases. Let's see if we are going to get that point. So I'm going to drag this out of the way and do menu 6. I want the minimum, and I'm going to click to the left, drag and click to the right. But again, it's not the exact, I mean, it is, to decimal places, it's as good as you're going to get, but we can trace menu 5, enter. Let's put 4 pi over 3. Boom, right there. So we actually got it, right? But from a calculus standpoint, we don't want to use these maximums and minimum things. What we want to do is we want to graph the derivative. So derivative with respect to x of f of x. And we want to see from the derivative. So here you can see the derivative changes from positive to negative at 2.0944. So there's an there's a relative maximum there, but more importantly, the function increases when the derivative is positive, so like from here to here, and then the function decreases when the derivative is negative, so between here, and then increases again. So visually, we can see that we definitely got this right. Let's go back to the notes and do the next one. Let's see. So the next one is a polynomial. Polynomials in general, like just easier to deal with, which is part of why, like, eventually you'll come to really love polynomials if you don't already. Mostly because, like, nothing you do is super easy, but they're the easiest. So let's find f prime. Okay, power rules. Although I think, like, almost every mistake that I've made has been on a polynomial, so, like, I don't know that they're necessarily my best friend. Factor 6 out a lot. 3s and 6s. I guess because you start with cubics, so it, like, kind of makes sense. I feel like we've done this problem. Maybe not like this, like not this exact problem, but I feel like I've factored this a couple times. And again, factoring is like super important. Make sure you know how to do it. Let's make a sign chart for f prime. So we want to label it -4 and 1. So I guess I should say like f prime of x equals 0. X is -4. X is 1. Okay, so I look at this, I see that f prime is a quadratic that opens up. A quadratic that opens up will always go positive, negative, positive, which is how I choose to fill these in. But you could test regions. You could say -1 billion definitely gives you negative times negative, which is positive, and then everything is the first degree, so it's all going to switch signs. You could test every region. Like, all of these things are options. Just like decide what you want to do and do it. So here I'll say f of x is increasing for x less than -4 and x greater than 1 because f prime of x is greater than 0 on those intervals. Sometimes I like accidentally kind of scroll while I'm writing and then nothing happens, and it, like, because my brain is used to using paper where like that doesn't happen, it's like I can't deal with it. All right, so these are the places where f is increasing because they're positives, and that's what we're looking for on f prime. If f prime is positive, f of x is increasing. So what I'm going to do is go to the calculator and just confirm. I mean, I'm feeling pretty good about this answer because everything like worked out really nicely, which I don't know if that's a reason to feel good about something, but I do. 2x cubed plus 9x squared minus 24x minus 10. Here we go. All right, so let's just go straight to the graph. All right, so let's graph f of x. Let's graph f prime of x. So derivative with respect to x of f of x. Okay, let's try to get a good window. So I'm gonna use, I do this all the time. First, you zoom out, zoom out, zoom out, zoom out, zoom out, zoom out. I think I can see everything I want. Now, zoom box. So like here, let's say. So I think I can see everything important. And let's do it again. Here to here. That's pretty good. And I'm gonna slide it over a little bit. Okay, so the blue one is the function, the red one is the derivative. So the function will be increasing when the derivative, the red graph, is positive. And you can see that it definitely is. The function is decreasing when the red graph is negative. So the blue graph is decreasing everywhere the red graph is negative, which it definitely is. These are the connections that you need to be making. So if you can make those, you're in a good place. I'm gonna add 0 to this. And then I'm gonna find menu 814, I'm gonna find where the red graph, the derivative, is equal to 0. Okay, so we can see that the zeros of the derivative are at -4 and 1, which is what we found. The derivative changes from positive to negative at x equals -4. So the function has a maximum, because when the derivative changes from positive to negative, that means the function changed from increasing to decreasing, which means the function must have had a maximum. So there's a maximum here. The same argument can be made at x equals 1, except the derivative is changing from negative to positive, which means the function is changing from decreasing to increasing, which means it must have had a minimum. And you can see the blue function does have a minimum where the derivative, the red function, changes from negative to positive. These are the connections that we're trying to make. So say things like that in your head a lot. Like look at a graph, look at its derivative. You have your calculator, you could go on GeoGebra, you could go on Desmos. You can do these things on your own and just get really comfortable with the idea. So if you can do that, you're in a really good place, because we're about to talk about something called the first derivative test, which I'm going to do in the next video. But that basically formalizes that concept. So I'm going to stop this video here. I'll be back in the next video to talk more about just all of these applications of taking derivatives, basically. And I will see you then.